Thank you very much, Adam. Hopefully my screen is being shared already. And it is just lovely to be with you all this afternoon. So so the first slide here is a little about who I am. So you type into ChatGPT, who is this Masberry? What does he know about AI in education? And it comes up with this sort of introduction. It's not inaccurate, but it's not entirely complete because it misses out really important stuff about me. Like I spent 18 years working as a teacher, much of that time as an ICT teacher, because we used to call this subject ICT back in those days. I did 3 years as a head teacher, which was quite enough. Thank you very much. I work at the University of Roehampton, training the next generation of outstanding teachers, and love this work very, very much. They let me out to do other interesting things. So I was part of the panel that drafted England's computing curriculum and been involved in lots of the sort of implementation projects over that, including currently chairing the National Centre for Computing Education's academic board, which is a great privilege. It really is. Right. So in England, we have a computing curriculum, but it's part of the national curriculum. And the national curriculum is there by law, and the legal requirements for our national curriculum, whatever that is that it must prepare pupils at the school for the opportunities, responsibilities and experiences of later life. And it is worth pausing for a moment to think about what that later life is going to be like for the kids in school today. What world are we preparing our pupils for? It seems very likely that artificial intelligence, in particular digital technology more generally, is going to play a really important part in their lives. And so part of our responsibility as educators is to prepare them as best as we possibly can for that world. The Department for Education recognises that some familiarity with AI tools ought to be part and parcel of what we do in schools. So advice from government now is that the education sector needs to teach students how to use emerging technology, such as generative AI, safely and appropriately. And I think it's fabulous that central government now recognises that that is something that we should be doing in school. This isn't an easy thing to do, as most of the tools that are available to us do have an age limit. You have to be like 13 or more, even with parental permission, to be able to use these tools yourself. But that doesn't mean to say we can't be making use of them in school. We as educators can be showing kids how these things work and how they can use these productively and safely and effectively. And further advice on the DFE slide there. As I say, as part of the panel that put together the computing curriculum, I think we did a good job. This is nearly 10 years ago that this took legal effect, of laying the ground for this. None of us at the time were saying, we have to teach kids about AI, we have to teach kids about machine learning, we have to teach kids about large language models. But we framed England's computing curriculum in such a way as to provide an opportunity for teachers to be able to take these ideas and run with them. So one of the central aims of the computing curriculum is that children should learn to evaluate and apply IT, including new or unfamiliar technologies, analytically to solve problems. So for them, that will include the large language models, ChatGPT, Gemini, Claude, and all of the rest. And they have to learn how to do that analytically and to solve problems. So there's a purposefulness to this. And then at the different key stages, I don't know how many of you are primary teachers, but even in key stage 1, kids should be learning to recognise common uses of IT beyond school. And whilst once upon a time that might have involved walking down to the secretary's office to admire the photocopier, these days that includes the smart speaker in their bedrooms that's listening into them, that's playing their latest Taylor Swift Eras Tour setlist or whatever to them, and listening in and helping them with homework in whatever way. And then you have more and more of that as they work their way up through the school. So 14 to 16, key stage 4, irrespective of whether they're doing a GCSE in computing, children should be taught to develop and apply their analytic, problem-solving, design and computational thinking skills. I don't think that excludes through the use of large language models, and I would say we would do our pupils a disservice if we didn't include that. So The way we went about designing that computing curriculum was to recognize the three separate strands, if you will, or overlapping strands of computing: the computer science, the information technology, and the digital literacy. It's much, much better to think of those as the foundations, the applications, and the implications of the subject, because that's a much clearer way of thinking about what we mean by computing. And the lovely thing is that that three-tier model of foundations, applications, implications applies just as much to thinking about AI education, teaching children how to use these tools. So yes, we should be addressing how this even works. How does it do this magic? But then a lot of the time we also need to look at how that can be used effectively, productively, and safely. And then stepping back from that to consider the implications of this. What does this mean for individuals? What does this mean for society? What does this mean even for education itself? So let me start then at the very beginning, a very good place to start, with this foundations tier. I'm just going to move my window slightly on screen and hope that that still works. So once upon a time, back in the days when I got my O-level in computer studies a very long time ago now, and still the way we're teaching this at Key Stage 4 is this idea of a computer is a machine. It accepts input, it processes that according to a stored program and produces output. This is still what we're teaching as a definition of what a computer is. The truth is it's changed since that very simple way of thinking about what a computer does. And these days, in most cases, the diagram, if we were to draw one, would look a lot closer to this than what you saw on the previous slide there. So the input is no longer directly linked to the output by the program, but is now linked to the output by some sort of model determined by the computer itself. Yes, we provide it with training data. We train it to see the connections between input and output. We select some sort of machine learning algorithm to help the machine or to allow the machine to make sense of that training data. But once we've done those bits, by and large, it's now just cranking the handle and the model is created from that training data according to the algorithm that's been selected. And explaining how input and output is connected is much, much harder to do now than it was in the days of, well, I've written a program here which does exactly that. Making kids aware of that change, that we move from if this then that to a much more complex and much harder to put your finger on model of how input and output are related. Lovely example from Jane Waite here for barefoot computing about this idea of a rule-based algorithm, which is actually really a data-based algorithm. In English, when you hear the or grapheme there, sorry, the or phoneme there, the or sound, the way that's actually written down varies a lot depending on the context. Sometimes it will be OR on screen there or on the text there, but sometimes it could be ORE as in more, score, before. Sometimes it could be an AW, so collection of graphemes as in saw, draw, yawn. The actual way that sound is represented is determined by rules. How does a machine decide that? Do you program those rules in? Or do you give it lots and lots of examples and expect it to learn from the examples? And where machine learning AI takes us is we learn from the examples there. So what you have on screen here is the representation of P, A, T, S, S. It's quite distinctive. And then I think I've got pat and tap. I can't remember what it is. And Pat's probably, no, that would be, I can't remember which order I did these in now. We can get kids writing code to make use of that. So here is in Dale Lane's wonderful extensions for Scratch, the machine learning for kids version of Scratch here. We've got a reading test working inside Scratch. On a good day, if it will play nicely with my microphone, I should be able to read these words aloud to it. Autumn. Spring. Simmer. summer. Wanter. And what we have there is it's listening to those sound pressure waves being picked up by my microphone, decoding those, mapping those onto the closest English word and seeing whether that matches the word that it was starting with. And getting kids to just work with this in Scratch is a really nice way into teaching them some aspects of this. What's my other lovely examples? If you've not played it already, do have a look at Quick Draw. This is like Pictionary on a computer. I'm very rubbish at this, but let's see how it goes. There's no guarantee the audio will work properly. So I've got to draw a flashlight in under 20 seconds. Here we go. So I don't know.
This is block or nail or shoe or computer keyboard or sleeping bag. I see bread or bed or toothpaste or submarine or couch. I see speedboat. Oh, I know it's flashlight.
Thank you. I got to draw the light waves. I'm not going to play any more of those because I am really quite rubbish at it. But you can get kids doing this. It's lovely to see how that has been trained with how people these labeled examples. So it knows what people have been asked to draw. It looks at the data of what people have drawn in response to that, and you can see the training data that it's worked with. And then it's a small step on from that to something like the PyTorch image recognition libraries. And again, getting kids to write code to do this. So what you have there is just the first stages to recognizing an image, just as we had with my Fourier transform of the sound waves there. What we have there is looking at the edges in this picture of a cat. And you can write the Python code to do that. And then you can draw on the pre-trained libraries to recognize that as a tabby cat. Pause for a moment's breath, right? Where we go now, of course, is not so much those lovely examples of trained classifiers, which is what I've been talking about so far, but into a more generative mode of AI. This is the sort of stochastic Markov processes of choosing randomly the next word from the words that you've seen already. Your pupils will all be very familiar with this because they're used to predictive text on their iPads and phones. If you look at a child trying to write a story on an iPad, very often they're just picking from the 3 suggestions that Apple's operating system comes up with above the keyboard. Rarely do you find them just typing the whole thing from scratch. So if we start with I'll call you, it says in, it says when, it says later, because that's the normally what people type next. And you can do this exercise with cards, and here are the text messages that people have sent. If you start a message with I'll call you when is the next most likely word to come up, and we've got the probability there if you want to do it. We can start modeling this on screen. This is, if you will, a small language model. And let's not look at generative AI in that huge sort of space of what ChatGPT does. But let's do this in a much, much smaller context of let's take the text, I think here is from Jane Austen's novels, and look for the 3-word groups in there. So if I have the first and the second word, the third word determined by the relative probabilities of those in the text of 3 Jane Austen novels. We've got the Python code on screen. It's not easy, but it's not beyond what we can do in Key Stage 4. So here we have it then. So if we have Jane Austen starts with the words I am, what's the next word in her particular trigrams? 3-word patterns. I am sure, I am not, I am very, I am afraid seems to be the words that she used next after starting with I am. And then, of course, we can start doing this recursively. If I have the first and the second word, I can pick randomly, according to these probabilities, what the third word is. If I have the second and the third word, I can pick randomly what the fourth word is. The third and the fourth word gives me the fifth, and so on. And here is my code in order to do that. So I'm just iterating over that model using random generation here to choose the next word. And we get sentences like, I am glad I did say that she should do Emma. Suppose we all know the ways of being never able to collect her thoughts. It isn't Jane Austen, but it follows something of the distribution of her vocabulary. kind of feels like Jane Austen-like English is nowhere near as sophisticated as ChatGPT and other large language models get us. So before November 22, when ChatGPT came out, am I getting the right date? Yes, okay. There was the ability to try it in its playground API mode as a completer. So here is my first few words here, tokens, we would say. Here are 5 ways in which AI can be used to provide access to the curriculum, and then ask it to choose randomly, according to the probability distribution of what it's seen in language, what words come next. And it, of course, guesses that the first bullet point is going to be numbered with a 1, then chooses what should I say? Oh, I say natural. Then once it's said natural, language processing, NLP, are obvious tokens to put down next. My example here on line 2 can be used to identify was the most likely, but it got a slightly lower score and went with analyze. Notice the US spelling, analyze student performance data. So it is at each stage rolling metaphorical dice and choosing according to the probability distribution from the language on which it's been trained which token to put down next. This explains how the hallucination thing happens, that sometimes it gets a low number and picks a bad word, and you all know that bad choices have consequences. And once it's put a token down, it's got no ability to go back and delete that. It has to continue that thought from the low number that it gave, and so comes up with something which isn't quite true. Never intends to deceive, but just it got a low score, it put an odd word down, and then has to carry on from there. I think you will find it's a little bit more complicated than that. Some of you may have been teaching the whole verbal reasoning thing, or will remember verbal reasoning puzzles. So you have, what is it here? That man is to king as woman is to queen is the obvious answer there. So this vector takes us from man located in this 3 space to king is parallel to the vector that takes us from woman to queen. The amazing thing to my mind is that this is invariant across languages. If we were to do this en français or auf Deutsch, we would get exactly the same position in this 3 space. We would get a parallel vector from one to t'other. And that idea of representing the word in some multidimensional space lies really at the heart of what we're able to do with language models now. And you don't train it you don't label these things and choosing the parameters yourself. These numbers are generated by looking at the word in context. This ability to pay attention to a particular property of the word lies at the heart of this. And this is why things like Google Translate work so incredibly well now. That what Google are doing now that they've thrown DeepMind at this is to think of the representation of each word in terms of its relationship to other words in English or in any other language, because these things do not seem to be language dependent. Right, what else do you need to know? What else do your pupils need to know? It's been trained on lots and lots of stuff. This was GPT-3, previous version of this, so loads of this is from a filtered copy of the open web, but 19 billion words, 22% of the training mix is taken from Web Text 2. Web Text 2 is the pages that people have linked to from Reddit. Not all of you will have Reddit accounts. Not all of you will have posted content to Reddit accounts. But if you ever did, then those pages became an important part of GPT's training mix, perhaps an overly important part of that. Some of you will remember the days when we said, you shouldn't be using Wikipedia, made up by people. Yeah, the rest of it's made up by people too. Wikipedia is 3% of the training mix for GPT-3. Paid a lot of attention to it. People involved too tend not to be particularly well paid. So the first stage of the human reinforcement of the language model there was these are good responses to these prompts. So we give it particular examples of how to respond to a prompt. Second stage was this is a better response than that. So remember, OpenAI, the firm who make GPT, have made a decision as to what a good response is, what the rules are for determining a better or a worse response. And that still goes on, so that you'll see the thumbs up, thumbs down thing at the end of responses to your prompts on GPT. And so you can get in there and say, these are better responses, and it will start to pay attention to those. Unless you tick the box or clear the tick in the box for you can use my prompts to continue training the model, there is the possibility, or you're allowing them to use what you ask it to train future versions of the model. GPT-4, the technical paper provides much less detail about how it was trained. They say, this report contains no further details about the architecture, model size, hardware, training compute, dataset construction, training method, or similar. So for the new version of this, GPT-4, they're not really being very, OpenAI are not being particularly open about how this has been trained. And you could say, shouldn't they explain to us how they've got to this point? Right, keep an eye on the clock and let's move on. Let's think a little about how we as teachers could make good use of these technologies. So again, DFE advice is teacher workload is an important issue. We want to identify opportunities to improve education and reduce workload using generative AI. So anytime when teachers can use these tools to save their time so they can spend their time better chatting to the kids, supporting the pupils with their learning, that's probably a good use of the technology. They say this is no substitute for having knowledge in long-term memory. To make the most of generative AI, we need to have the knowledge to draw on, and reasons why that's the case. There's a whole host of little platforms out there, the sort of tile-based interface to creating the prompt. These aren't their own large language models. They're acting as interfaces to, typically GPT 3.5 for most of these. So you click on the tile, you give it a few parameters, it then fires off that prompt to GPT 3.5 and gives you the response in a particular format. You can use this if you'd like, of course you can, and lots of opportunities or reasons why you might want to. But here I'm just suggesting this. These are things which it might make sense for you as teachers to use it to save time doing some of this really quite tedious writing text stuff. I love the Magic School AI one because it has the teacher joke generator. How fabulous is that? You know that feeling on a Sunday evening of, I've not prepared my jokes for the week ahead. So go on to Magic School AI, give it a few parameters, and it will generate the jokes for you. They will go down very well, I'm sure. Okay. The DFE did the consultation exercise last summer, not a time when many teachers are responding to consultation exercises. These were what teachers said they were already using large language models to do. I like the one at the bottom here about using it to proofread, edit, or improve written content, and I do a lot of that myself. Also, interestingly, for us as computing educators, this notion of using it to support coding, I think that's really interesting. But, you know, these things are not, I think they all make sense to us, and some of you, I'm sure, will have done these things before yourself. Okay, I have a little worked example here looking at, I've got to teach Year 8 a sequence of lessons about digital piracy. My first thing, the sort of zero-shot prompt is, tell me about digital piracy. And you will start to see this approach in its responses. It gives you a little introductory paragraph, and then it goes into maybe 4, 5, 6 bullet points about each of these. It's a helpful format, but after a while, you start to spot that in things other people claim they have written. Much more useful for us as teachers. Okay, give me this as text that I can put in front of my Year 7 class, and it's a really nice little summary of that. I could have written this myself, but very rarely do I have time to do this sort of work. Okay, you're an expert teacher of computer science working in an English secondary school. Your school uses the I do, we do, you do structure for lesson planning. Write me a lesson plan for an engaging Year 8 lesson on digital piracy. And comes up immediately with a lesson in response to that. It's okay. I don't think it does it any better if you tell it that it's an expert teacher, but it will follow the I do, we do, you do thing that I've suggested there. And it does weird stuff at the end. So section 5, assessment, creativity and accuracy in the digital poster infographic. It's kind of done me a lesson, very old school ICT, of go onto the internet, find out about this and make me a presentation. It's not brilliant. Oh, and then it makes it worse. Use varied teaching methods, visual, auditory, kinesthetic, to engage all learning styles. And I have to come back and enter into a dialogue with it and say, that's a really bad idea. No evidence in support of this. Give me another way of doing this. Some of you, I suspect, will have tried the whole flipped classroom thing. My problem with flipped classrooms is, how do I know they've actually watched the content beforehand? So here's a lovely TED talk on digital piracy. I get the transcript from that and give me a summary of this. It gives me a single paragraph summary of what Douglas talks about in his TED talk here. Then I can do more. I can say, no, we don't want to see the talk. Next slide, please. Okay, based on this transcript, create for me 5 multiple choice questions that I could use to check whether the kids have watched the talk before the lesson. And now, this is the sort of thing which I really am not likely to find much time to do. By setting them these questions and by asking it, make it hard for someone to just guess the right answer if they haven't watched the talk, I should get a good set of questions which test whether they have actually watched and retained knowledge of this. And then I ask it to give me these as a PDF. The reason I ask for them as a PDF is then I can ping that PDF into Office forms and get those as a beautiful Teams-based or Office-based quiz that I can get my pupils to answer online, and I get the score out of 5 for how well they've watched those. The image generation stuff is fabulous. This is done using Midjourney, which is like the cutting edge here. So the prompt was reasonably well crafted. I asked for photorealistic, I asked for shallow depth of field, but as a starting point for inspiring children to think about digital piracy, sometimes going to an image-based thing rather than just here is a lesson plan may be more effective. Other things you can do. So some of you will be using Sue's lovely PRIM method for teaching programming, which is built into a lot of the Teach Computing curriculum. So we have this predict, run, investigate, modify, make. If you tell it what PRIM means, as I do here, and then say, base it on this program, and on this particular occasion, I forgot to give it the code. It went off and wrote the code for me and then produced a really nice worksheet using PRIM based around the code that it has to generate for me. It goes further than this. It comes up with guidance for using the worksheet, tips for the students, notes for the teachers. It's done a really, really good job of this. I don't know if any of you are using William Lau's lovely idea of fertile questions in computing, but coming up with a good question often way more important than knowing the answers to it. And I love this one. It's again generated by the machine. I tell it what a fertile question is and then say, give me some examples for computing. How do different programming languages shape the way we solve problems? I'll give you a moment to post your response into the chat. No, okay. I love what Gemini does with this. Let's see if I can get Gemini up and running. Okay, and this has voice recognition built into it. So let's have a go at this. I'd like you to role play as Ada Lovelace. I'm only 12 years old. Keep your responses relatively brief. I want to have a conversation with you about the early history of computing. Send that off and it responds. Okay, so gets this idea of going into character with this. So, if you had Ada Lovelace in your classroom, what would you ask her? Is it true that you were the first computer programmer? And, okay, and it's got a good response. Let's listen to her.
That's a question that sparks debate even among grown-ups. Some say my work with Charles Babbage's analytical engine, though theoretical, was the first computer program.
I have no idea whether the audio works across this medium. Let me move on. Okay, so that to my mind is a really lovely way of demoing a lot of this in class. We have this whole thing about writing reports. I'm not going to dwell on that. Let's move on. I don't think as teachers you need to worry too much about going on the courses to do prompt engineering or prompt craft. I think we as educators are really good at coming up with the right question to ask, the right prompt. And we go into this. We don't just give them the worksheet and forget about it. We engage in a conversation. We expect them to be able to explain their reasoning. We learn as part of our craft of teaching that we need to be clear and precise in our instructions. So much of the time, I think what you are learning as ITT, as English teacher training students and as early career teachers is actually how to prompt your pupils well. Take those skills and use those when you're working with the machine, or practice your prompting skills for class by prompting the machine well. Okay, we've got about 10 minutes. Let me talk a little about how your pupils may be using some of these. I don't think there are going to be many kids who are using the Scratch plugin to GPT to generate Scratch programs, but it is possible. The Scratch code is not good. It's not syntactically correct, but I'm just so impressed by the idea that it can even do that. So a lot of our time as computing educators is taken up with fixing the mistakes our pupils make. I would very much like to move to a place where we do not do that anymore, that they have permission to start using the tools to help them debug code. And again, with a little bit longer, paste into the chat, what the mistakes are here. There's loads of bugs in this code. And it's an interesting exercise. It's worth thinking about finding those mistakes. But I can just paste that code into my AI here and say, okay, what mistakes have I made? And it gives me a good list of those, including the logic one, which lots of real people seem to miss, and gives me then a working program at the end. Powerful learning? I don't know. But I think this is better than them waiting for you to come and fix their code. It's not as good as them fixing their code themselves. And I had this horrible experience with my trainees of trying to do quick sort from memory on the big screen at the front of the room and struggling. This was as far as I got. So, what do we do when I got it wrong at this point? Do I say, okay, let's have a coffee. I will fix this over the coffee break. These days, what I can do is just paste this into ChatGPT and say, fix this for me. And, a pupil has got vaguely the right idea of how to do a recursive quicksort. Can paste that in and get the corrected version out. We used to have these non-exam assessments. We removed those from the GCSE because loads of kids were just posting the question up on Stack Overflow or Student Room or wherever, and then just getting other people to solve it for them. These days, of course, you would just paste that into ChatGPT and you get a brilliant solution back. I'm more interested in using it in assessment in a positive way. So if a child takes a photograph of their own response to one of those long 6-8 mark jobby questions and sends that to GPT and says, can you suggest how I could improve on this answer? Apart from the age restriction, I don't see there's any problem with that. There are a few issues with you pasting their work into the machine and using its feedback as your own feedback to the pupil. I don't think that's entirely honest. Them learning how to get feedback on this themselves seems entirely appropriate. There are limits to this. I had an interesting argument at lunchtime today about whether it can reason. I don't think it can reason at the moment, but it can feel as though it is reasoning. It's not thinking. It is just predicting the next token to put down. But on the other hand, if it can fake understanding and reasoning, isn't that the same as understanding and reasoning? There are issues around maths which are really interesting. It's really good at saying what to put next after everything it's seen so far. It's less good at aiming for a particular goal. And then it will get better and better at this. But, there's this lovely NIM game. Google it. I'm not going to Google it for you now. Learn how to play NIM. It's a really great way of introducing computational thinking. If you ask it, how do I play a perfect game of NIM? It will give you a good method of winning at NIM. If you then say, play NIM with me, try and win, at the moment it can't do that because it doesn't have that thinking ahead. All it has is a thinking, looking back and saying what comes next. Okay, right. So the biggie for us as computing educators is, look, isn't this all now a waste of time? why should we even teach them how to code when the machine is so much better at writing code than almost everybody on the call now, I suspect. Coding, this changes the nature of coding. So it becomes something which anyone can now do. I've got a problem. I know that there would be a way to solve this if only I could program this. This is where GPT and its friends come into their own. They are really good at writing the code to solve your problem if you specify it well enough. And then this idea that actually coding is a solved problem now for all but the very specialized applications. Most software will be replaced by AI systems that are trained rather than programmed. Some of you will have done Phil's lovely jam sandwich algorithm thing. You don't program a robot to make jam sandwiches by giving it instructions. You get a robot to make jam sandwiches by showing it videos of people making jam sandwiches and realizing that we move beyond that input process output to input training data and model output is crucial to the agenda now. The lovely paper from Brett Becker and others that actually this changes how we teach this, and a recognition that what will matter moving forward is not your ability to write code, but much more your ability to read and understand and check code. And yeah, really interesting work that we're starting to see emerge, that actually the kids or the students, this is first year undergraduates, who've got access to the Codex-like tools, Copilot and its friends, not only are really good at solving the problems, but seem to remember how to solve those. I think it's early days, but the initial findings are positive. Actually using this to help you may not have the negative implications that we thought it would. For Barefoot, we had this lovely thing about computational thinkers, and so much of what we've done is focus on the left side of the diagram here about logic and algorithms and decomposition, patterns, abstraction, evaluation. You will have all taught those lessons. Turns out that the machines are really good at that left-hand side. They're much less good at the stuff on the right-hand side. So again, I think as we move forward in computing education in this era, we move our focus away from algorithms and abstraction to tinkering, to making things, to, yeah, fixing things, but perseverance and collaboration become really, really important. I will move on. Right, a few minutes left. Academic integrity. Okay, so those of you who are still doing initial teacher training, do not cheat. What do we mean by cheating? Generally, when I do this talk, the first three on this slide, everybody agrees they're fine. Getting it to explain something to you. Coursework is contentious here, so homework is better. And homework here. Because coursework, there are rules, but homework is another matter entirely. Slideshow, presenter view. Right, okay. So explaining something to you, giving you ideas for your homework, suggesting how to improve your homework seem to be fine because kids can ask one another, kids can ask their parents, kids can ask you for help with those three things. Getting you or their friends or their parents to do the homework is a whole other matter. They don't do that. We wouldn't let them use the AI, shouldn't let them use the AIs to do that. There seems a clear moral line between item 3 and item 4 on the list. Those of you who are preparing pupils for GCSE or A-level need to know that the work that's accepted for assessment has to be the student's own, and you need to know that it's the student's own. This doesn't apply as much now to GCSE as it used to, but for A-level, the coursework, the non-exam assessment, how do you know that's the pupil's own work and not the AI's contribution? Becomes an interesting question. Again, if you're working with sixth formers, their UCAS application, their personal statement has to be their own personal statement. The UCAS's advice is really smart on this. It's fine to use it to get ideas, to help with the structure, to check for readability. But do not copy and paste from the AI tools and use that as a final text. Universities will not generally be impressed by candidates who've done that. Right, 1.5 minutes, broader implications. I think transparency is really important with this. If you're using it, say you're using it. I really am worried about the environmental impact of training some of these large models. There is law which says decisions with legal effect, significant legal or significant effects have to have a person in the loop. Grading GCSE papers is probably a decision which has significant legal effect. The terms and conditions do apply. For most of these services, you have to be over the age of 13 and below the age of 18. That typically is going to mean having parental consent. Let me just step out of the slide deck, see if there's anything. Oh yes, let's just quickly put this on screen about the bias here. So what you see on my slide there are pictures of AI generated, pictures of a computer scientist on the left and a programmer on the right. I hope you are appalled as I am by how awfully stereotypical these are. These people all have something in common. They're all having to wear spectacles because they stare at a screen for far too long. There are other things they have in common. It gets, is this worse or better? This is, again, is Midjourney's lovely work, but this is, show me a picture of a child programming a computer, show me a picture of a teenager programming a computer. And whilst we do not want to make assumptions about gender, I think it has made assumptions about gender. And isn't that just awful? And poor chap at the bottom right here is already having to wear the spectacles because he's been staring at a screen for far too long. Yeah, Turing, in order to use OpenAI, I'm now the one who has to tick the box to prove that I am human. I think there is more that makes me a human being than my ability to put a tick in this box or to identify pictures which have traffic lights in them. I think we need to recognize that the humanity that we are trying to inculcate at school. That's it. Okay, I've rushed through some of those slides. But listen, it's been so lovely to talk to you this afternoon. It really has. I will hang around. I will stop sharing my screen in a moment and see if there's anything been posted into the chat or if anybody wants to unmute and chat. Otherwise, I will hand back to the wonderful Adam and Tracy. I click on the stop sharing button.